of the weather, but I think we're good. Is this recording yet? I think it is. Yeah, it is. Okay, so what we have coming up, okay, you have two old assignments. You have the Saving Planet Earth film facts. Today is the last day, and I still have several of you guys who haven't finished them yet. Several of you guys haven't finished the old assignment from last Monday. Okay, Saving Planet Earth film facts. Today is the last day for that. Then on last Tuesday, I gave you the gray box. Let's see who that's. Alian and 950. Okay, 950, and who else? Andrew, 950. Okay, I think that's just about everybody now. Okay, so again, the assignment I gave you last Monday was Saving Planet Earth film facts. Today is the last day for that. Gray box, page 417. I gave that to you Tuesday. The last day for that is tomorrow. And there's several of you who haven't turned in both of those things, but most of you have already. Moving to the more current stuff. Okay, Dedrick, I'll have to get to that question for you in a little while. Okay. All right. So then moving into the more recent work, the notes were due on this past Tuesday. They are an 80 today. If they're not in yet, I'll grade them this weekend. The TED Ed energy efficiency is already graded and in Power School already. But if it's not done, today's an 80 on that one also. Now, yesterday, the building efficiency was due. Yesterday, that was due. Today, it's a 90. Okay. And then I'll give you your study guide for this section tomorrow. Okay. So that's everything that's coming up due. Okay. And again, if this was crazy, just look at your assignments list in Teams. It's all spelled out for you right there. All right, so moving on to our discussion for energy efficiency. All right, let's see how much I can fix this a little bit. Okay, this is a little bit weird and it's a little tricky to work with, so just deal with me. All right, so energy efficiency, okay, is a measure of how much useful work can be obtained for each unit of energy used. All right, now what that means is if we are measuring in kilocalories, then how much work can you get done per kilocalorie? Or if we're measuring in joules, how much work can you get done per unit of joules? Because we have a bunch of different things we can measure energy in. So efficiency is how much work did you get done per that one unit? And what we know is that we waste so much energy that if we started to be more efficient with our energy, it'd be like adding a whole new resource. Let me show you what I'm talking about. The resources. We've got coal, oil, natural gas. Those are the bad ones that we talked about on the last unit. Then we've got wind and water and solar and several others. Okay, that's what we're going to talk about in this section. Those are our resources, right? The bad ones, coal, oil, natural gas, and nuclear. Those are the bad ones. And then wind, water, solar, geothermal, those are the good ones. If we started to be more efficient, we could save as much energy as if we were adding an extra one. Coal, oil, natural gas, nuclear, wind, water, power, solar, and energy efficiency. We waste that much that if we started being more efficient, it'd be like adding a whole nother resource. Okay, that's why it's worth having a whole section to itself. All right, so and this is where it gets a little weird. I've got to match these to the right size. Okay, so energy efficiency, again, the definition is the measure to how much useful work can be done per unit of energy work, a unit of energy used. Okay, so whatever we're measuring in, how much work can you get done per that unit of energy? Improvements in energy efficiency could save at least a third of the amount of energy worldwide, but 43% of energy in the US. That's almost half. Okay, the rest of the world, it'd save a third. The US, it'd save almost half because we are crazy wasteful. We are more wasteful than anybody else. So we could save almost half of our energy if we were just more efficient. Okay, and we actually already have a variety of technologies already available to help us do this. We already have technologies available. We just need to use them. Okay, whether we're talking about industry and factories, or whether we're talking about motor vehicles or the different appliances, like if you got a new computer that has a good star rating, or that star rating on refrigerators, microwaves, freezers, computers, there's an Energy Star rating that lets you know how efficient it is. So if you get something with a good Energy Star rating, then you're getting a good appliance. And then our buildings, we'll talk about that in a little bit, exactly how wasteful, and you saw that in the videos yesterday, how wasteful a building can be. And if we were more efficient with our energy in the buildings, we could go a long way towards saving uh, resources. All right, so I'm going to pull this diagram pretty big so we can see it good. Maybe not that big. That's too big. So again, you have to just put up with me on how crazy this is. All right. All right. Try again. All right, this should work. I think I can see everything. Yeah, pretty much everything. Okay, yeah, I can see everything. All right, so this is the energy that's going into the system right now. This is the energy we use. This is the energy we put in. We put in 87% of the non-renewable fossil fuels, coal, oil, natural gas. This is the bad stuff. And we put in 8% of nuclear. Okay, this is what we use to do our work. So 87% bad fossil fuels, 8% nuclear, even scarier. Okay, we only use 5% of the good stuff. Now, this book was written in the 2014, 2015, so it's possible we've made some advances, and I certainly hope we have. Okay, but these are the numbers we're going to work with for our test. All right, so this is what we put into the system. 87% of the non-renewable fossil fuels, 8% nuclear, and only 5% good. All right, now what do we get out of it? We only get 9% out of all this that we put in. 9% of this is useful. And 7% we're making petrochemicals. This is making stuff out of the energy, physically making stuff. All right, so these two are okay. They would be these are the two good things. This 41% here, this is the unavoidable energy loss. Do you remember we talked about in the last section, we talked about the second law of thermodynamics? And what that meant was that anytime you do work or you spend energy, you're going to release some of that energy as wasted heat, and there's nothing you can do about that. That's the second law of thermodynamics, that every time you do something, some of it will be wasted as heat. Now you can get more efficient and less will be wasted, but there's always going to be some wasted as heat. So what we can change is this last one, this 43%. This is how much is wasted. This is why the US is in trouble as far as energy efficiency goes. We waste 43% of the energy we put in. So if we were to take this 43% and add it up, stop wasting it, and add it up to the 9, can you imagine how much better this would be? And if we were able to put the good energies in, instead of, switch this 5%, switch it for the 87. Or maybe combine the fossil and the fossil and the nuclear we still use and make that a line way up here at the top, and all of the rest was the good stuff, and then we stop wasting so much. That's what we're talking about here in this section. All right, so let me get this back down. So this diagram shows us the flow of the commercial energy in the US, and only 16%, that's that 9 and 7 up here, only 16% of the country's high quality energy winds up being useful. Okay, the 9% useful and the 7% chemicals that we are making with this stuff. All right, so what we need to do is we need to cut this energy loss and improve our efficiency. So people can cut energy waste by using mass transit, driving more energy efficient vehicles. Now that's one of the main things, mass transit. If we had something that was decent, think about in New York, where people ride those commuter trains to get back and forth and around anywhere. What if we had something like that here? For myself, I live in South Haven. All right. I have a 25-minute drive back and forth every single day, just me and my truck by myself. Okay, there is a whole lot wrong with that statement right there. All right. First off, it's a truck. It's not an energy efficient vehicle. Second off, it's just me. One person, one car hogging up that interstate. If we had mass transit, there is a railroad right here that drops off by the school. And there's also one near my house. If I was able to get on the train and come up here to work every day, my truck wouldn't be on the highway. All the gasoline I'm using, I wouldn't need. And I would be able to work while I was on the train. Okay, it would be so awesome if we had this available to us, which is one of the things I'm saying, guys. If you are looking to make a difference, your job might be to make some of this happen. Okay, Miss Gales always has ways for you to make $1 million. If you were able to be one of the people to set this up for us, you would be rich. I'm telling you, I've got ideas. Okay, all right. So the other things we could do to improve our efficiency is buy more energy efficient devices. Like I'm telling you, the computers, the microwaves, the refrigerators, the freezers. If you get those Energy Star rating ones, you get more energy efficient. We could simply change some of our habits. Turning off the lights when we're supposed to, right here. Turning off the lights, unplugging the electric devices. Like they call computers electric vampires, because even when you're not using it, it's just in standby mode, it's still sucking up a lot of energy. So actually unplug it, use a surge protector to turn it off. Okay, something like that. So again, the definition one more time to make sure you got it is how much useful work we get from each unit of energy, and the advantages of reducing energy waste. Okay, it's usually the cheapest way to get more energy. How expensive is it to turn off your light? You don't have to buy anything. You don't have to do anything. You don't have to make anything. You don't have to buy anything. Just turn off your light. Make some good decisions. It reduces pollution and degradation. If you are using less electricity, the coal power plant doesn't have to dig up the ground to get more coal. Think about it. If we stop using so much energy, the coal power plant doesn't have to go dig it out of the ground. It doesn't have to burn it to boil the water. So you're saving pollution and degradation if you just be more efficient with the energy we have. It slows down atmospheric warming, again, because we're not burning all of this coal to run the power plants. And it increases economic and national security. If we do not have to worry about going to war with the Middle East over their oil, remember, because it's oil that makes the gasoline for our cars. If we don't have to worry about going to war for oil because we are driving efficient vehicles, we're driving electrics and hybrids. Therefore, we don't need Middle East oil. We don't have to worry about national security. We also have economic security. Can you imagine? There's a whole bunch of movies put out when you run out of gasoline or something happens with the power grid and people just go apocalyptic all over you, right? You have mass hysteria, fights, wars, you know, downtown cities look like war zones because people are fighting over resources. Now, these are the movies, but it's based on what could really happen if we wound up not having this stuff. So if we save our energy, we will have more energy. Okay. All right. Now this is really small, so give me another minute to get this big enough to see. So these are different ways that we use our energy inefficiently. Okay. Yeah, because I've got data centers on another page, so that's fine. So right now, living and working in buildings with poor heating and cooling, this is one of the things we do. That's why you were watching the building video yesterday. All right, imagine it's summertime, it's hot as who knows what. You're running the air conditioner full blast just so that you can breathe. All right, but you've got old windows on the house and the cold is going out through the windows. Or worse, you have a toddler in the house or a little kid, little brother, sister, cousin, whatever, who won't shut the dang door. You know what I'm talking about, inefficient heating and cooling. All right, so that's one of the things we do. Commuting to work alone, which I just talked about. Driving vehicles that use gas inefficiently. Like I'm driving an old truck. All right, so these are different things that a lot of people do. 3 widely used devices that waste the energy. The incandescent bulb, those are the old-fashioned bulbs. Okay. Motor vehicles with internal combustion engine. Internal combustion engine. That means the old ones, the regular cars. That means regular. Okay, because you'll see that again. You need to know which one that is. Internal combustion engine, that's just a regular car, as opposed to electric or hybrid or something. Okay, that's what you call the regular cars. And then, of course, industrial motors. If you have to have like a big motor to do something in your factory, what they do is they run those motors full blast. And even if you're trying to do something delicate, what they'll do is they'll run the motor full blast, but then throttle it back so that you can do whatever this thing is that's delicate. Rather than, there are motors that can, if you need to do something delicate, they can turn the motor down. Okay, so they're called variable speed motors. Now listen again to what's happening in real life right now. What's happening is they run the motor full blast all the time, and then they throttle it back when they need to do something delicate. But there are new motors that if you need something delicate, it only turns on partially. Those are variable speed motors. And if we had those in all of the factories, we'd be wasting a lot less. Okay, the next, got data centers on this next page by itself. Okay, because data centers, because of the way we're doing computers and everything is so important right now as computers go, this is very important. And again, you saw an example of the data centers in the video from the other day. All right, so the data centers, hang on, let's do one more picture. Alt print screen. All right, and down here, 10:05. 05, paste, save, minimize. Okay, all right, so think about Amazon and Google and Walmart.com and Facebook and Instagram. All of this computer stuff all have to have giant data centers to handle their computer traffic back and forth. These data centers are very, very wasteful. For all the energy that they take in, they actually only use about 10% of it. So 90% of that energy is wasted as heat. Remember the second law of thermodynamics I was talking about? Because these computers run hot. Okay, large amounts of energy has to be used to cool down these computers, and they run 24 hours a day at maximum, regardless of what you need. Think about computer use, like Instagram or something like that. How many people are on Instagram at like 5 or 6 in the evening when they get off of work, as compared to 3 or 4 in the morning? Okay, yes, there will be some people still on at 3 or 4 in the morning, but not nearly as many as are on at 5 in the afternoon. So they run their computers full blast, maximum capacity all the time, when in reality, they need to shift it per time of day as far as their traffic goes. All right, and that's one of the things that they talked about with your this data center thing. Also, this is just an example of one of the industries that is very wasteful. Another industry that's wasteful is manufacturing. Okay, think about how much energy it takes to melt metal to make steel. Okay, I'm going to talk about that with this next thing, I think. All right, I think. Hang on, turn the page. Yeah, cogeneration. All right, so cogeneration is a way to produce two forms of useful energy from one fuel source. All right, and the example of that is if you think about the utility companies, remember how I told you how a turbine works? They boil water to make steam to spin the turbine. Okay, that's how coal and nuclear and most of the power plant, even solar, works that way. Okay, you boil water to make steam. All right, the heat that is produced when you're trying to boil the water could be used to heat whatever building you're in. Think about it. You're boiling water to make steam. The heat that is used to boil water could heat the building. That's cogeneration. Two forms of energy from the same fuel source. And that way you don't have to have a separate, electric run heating whatever. You're using the heat you use, the same heat you boil water with, you're using to heat the building. That's called combined heat and power. Combined heat and power. All right. That would another way we save this, replacing these electric motors like I talked about. These are different things we can do to save it more efficiency. We can recycle our materials, and we can switch from the low incandescent lights to the higher LED. All right. Now here's our example of cogeneration. Okay, like I was telling you with the boiling the water to make steam. All right. Also, industrial plants, manufacturing industry would be one of the best ones to try this, to use this cogeneration. The manufacturing industry would be one of the best ones to use cogeneration, because think about the processes it takes to make concrete or to make steel. All of that you have to do. Okay, all of that you have to do to melt the metal to make steel, that heat is immense. So you could use that heat probably to heat not only the building you're in, but several other buildings nearby. All right, so that would be really, really useful in the manufacturing industry to use cogeneration. Now, the next part is our smart grid. All right, smart grid. Improving the transmission of energy through an updated electrical smart grid will save money, make delivery more efficient and reliable, better incorporate renewable activities, and provide more control to customers. Let me work out on the specifics on each one of those things. All right. So smart grids. All right, let me get to the picture because I'll show you with the picture. It's easier. Okay. All right, so smart grids. These are digitally run. All right, and what they do is they are bigger. Right now, MLGW is just Memphis. These things are nationwide. All right, so that's going to have a couple of different things, like different parts of a region. So you'd have maybe 5 or 6 states together or 8 or 10 states together. All right, so what you do here is this is the control center. It's run by digital. Is everybody listening, paying attention? Yes? Kennedy laughing into her phone. Yeah, Kennedy's having a good time. You guys focus, please. Okay. All right, so this is our digitally controlled control tower. Over here we have a wind farm, okay? And over here we have a solar farm. All right. One of the things about the smart grid is that it allows you to bring these renewables in more easily. Let's say this solar farm is out in the desert somewhere, because that's where solar farms would be better. But the smart grid is such that it has really, really high voltage, super efficient transmission lines. Right now, MLGW burns its coal and sends the electricity down the wires, but the wires are not really efficient to go very far. The electrical grid system is almost 200 years old. All right, almost 200 years old, and the wires in it are not great. So when MLGW, the different power plants of MLGW burn their coal and try to send it down the wires, it won't go very far. With the smart grid, the wires themselves are ultra high voltage and really super efficient, so that when it's sent down the wires, the energy's not lost, it makes it to its location, and you're allowed to have further distances, because this solar farm in a deserty area and this wind farm, like we're in Tornado Alley. I don't know if you remember it when you learned your weather in probably in middle school when you learned weather, but we're part of Tornado Alley. So wind is something we've got. Wind is something we have almost all the time. So in an area like this with a wind farm, an area out in the desert, or worse, like flat, like Arkansas is so flat. All right. So you can have solar farms out there as well. And here's some smart houses with solar panels on the top of them. Let's say you were an architect and you were designing a whole neighborhood. And they do that here, especially, you've seen where the new neighborhoods come up and you have like 200 or 300 houses built at one time in this neighborhood, and then they sell all those houses, right? That happens here a lot because the population is growing. What if the person who's designing that neighborhood decided that every one of these houses is going to have solar panels? You're allowed to do that, which is another thing that you guys can earn $1 bajillion on. Okay, so what if you decide that every house in this neighborhood is going to have solar panels? Well, think about it. When the sun is shining outside and it's bright sunny day, but everybody in the house is at work, all of that energy that is made by the solar panels gets sent out to the neighboring houses because you didn't need it in your house. Everybody's at work. When your solar energy gets sent out to the neighboring houses, MLGW pays you a check. Do you hear how awesome that would be? Okay, because your houses are connected to the grid, if you have more energy in your house than you need, it goes out to the neighboring houses and MLGW pays you a check. So that's one of the things of a smart grid right here. And also the fact of the positioning of the buildings. Here's the factories over here, again, probably using cogeneration, so heating would be sent out nearby. And here's buildings, offices, and such. All right, you know that people are going to be in the offices from about 9 to 5, right? And they'll be at home from 5 to 10 or 11 before they go to bed. All right, the energy, the offices and factories will need more energy during the day, and the houses will need less energy during the day. Right now, MLGW sends all of that everywhere. They send the same amount of energy everywhere. But if with a smart grid, you can divide it up, send more energy out to the offices and buildings during the day and less at night, and switch it. Send more at home in the evenings and less during the day. So that's another thing that the smart grid can do. And here is a huge electric vehicle car park. Remember, if we're all going to be driving electric vehicles, we need a place to charge our cars. All right, so, and again, I think we'll do the discussion on the vehicles tomorrow. All right, because we are coming close to time. So this is different things that the smart grid can do for us. It's ultra high voltage wires. Hang on, whoops, dang it. Hang on, let me fix that real quick. Shoot. Trying to be fast and I'm making a mess. All right, so, oh, stop. It's hard to grab it when it's this small. Anyway, whatever, I'll just leave it there. Okay, so we have this ultra high voltage, super efficient transmission lines. Like I said, the ones we have now are tiny and pretty useless. We would need big wires in order to cover these distances. It would be digitally controlled so that you can get the power to the places that need it and save it in the places that don't. It will respond to local changes in demand and supply, and much easier to buy renewable energy. Like I said, that neighborhood with the solar panels on top, you can just send it into the grid and get a paycheck. Okay, so I think that is as far, yeah, because we'll start the efficiency vehicles tomorrow when we finish up our discussion. All right, let me grab the thing, slide it over, take one more picture. All right, do you guys have any questions for me? Okay, let me see. Let me run my meeting list. We are very close to time to go. Not quite yet, but just close. 4:29, 21, and y'all are fourth. Save and get this picture on. Do you guys have any questions? So again, thinking through the details, we'll finish our discussion tomorrow, and I'll give you your study guide, and we'll take the test on Wednesday. 10:17. Paste and save. Minimize. Okay. So what do you guys think? So again, some of the things that I was talking about for making a bajillion bucks, right? You guys can be one of the people who sets up the trains from Memphis. We need that train center set up here like we have in like they have in New York. You can be one of the ones who spearheads that. You can be one of the ones who spearheads the building the neighborhoods that have solar panels on it. You could be one of the ones who sets up wind farms. You could build a wind farm or a solar farm depending on where you are. You can be one of the ones who with the trash pickup and recycling, you know that when those landfills compost, it makes methane gas. You could sell that. Okay, you could be one of the ones who designs the building efficiency data centers. Okay, right now in South Haven, near our Tanger outlet in South Haven, we have a Google coming in and we have an Amazon. We have 2 data centers right now being built in South Haven. All right, so if you can be one of these people who design these things to be energy efficient, so there's thousands of ways, okay, that that you can be part of this, and if you're willing to take charge, you could be a millionaire. But even if you're not ready to run something, learning to be more energy efficient, we don't all get to have a new house. Okay, I'll talk about when you the building. We don't all get to have a new house. We don't all get to build a house fresh. Most of us are going to inherit an older house. And some of the things I'm going to teach you tomorrow's lesson is how do you make that older house more energy efficient so you have to give less of your paycheck to MLGW. All right. Do you guys have any questions at all? Okay, I'm going to stop the recording. All right.